Let's imagine a square with 4 pieces. If I wanted to get 3 pieces of this square, this can be represented by writing 3 over 4, where 3 is what is shaded and 4 is the whole square or all of the pieces. If I multiply 3 over 4 by 1, the result will be 3 over 4. Nothing would change because the product of any number and 1 is that number. Now, if I multiply 3 over 4 by 4 over 4, which is equivalent to 1, and use our understanding of multiplying fractions, the result will be 12 over 16, which can be visualized by shading 12 pieces out of 16. Notice how we increase the number of pieces, but the area shaded stays the same. With this understanding, we can say with confidence that 3 over 4 and 12 over 16 are equivalent fractions. Now let's say we wanted to add 3 over 4 plus 12 over 16. At first glance, we might want to use our understanding of adding fractions, but if we look closer, we can see that the denominators are not the same. So, in order to add or subtract fractions with different denominators, we first write the fractions as equivalent fractions with the same denominator. So, if we take a look at some of the multiples of 4 and 16, we can see that 4 and 16 have 16 in common, and they also have 32 in common. The least common multiple, or LCD, will be 16. So, if we multiply 3 over 4 times 4 over 4, we get the equivalent fraction 12 over 16. And since the other fraction has 16 in the denominator already, we can just bring it down. At this point, the denominators are the same, so we can add the fractions to get 24 over 16. Now 24 over 16 is indeed the answer, but it's not simplified. So if we write the numerator and the denominator as product of primes, we get this. We then can cross out 8 from the numerator and the denominator to be left with 3 over 2, which is the simplified fraction for 3 over 4 plus 12 over 16. Let's do some examples. First up is 2 over 5 plus 1 over 4. So if we take a look at the multiples of 5 and 4, we can see that 5 and 4 have 20 in common, and they also have 40 in common. The least common multiple, or LCD, will be 20. So, if we multiply 2 over 5 by 4 over 4, we get the equivalent fraction 8 over 20. And if we multiply 1 over 4 by 5 over 5, we get 5 over 20. Now, since the denominators are the same, we can use our understanding of adding fractions with the same denominator to get 13 over 20, which is the simplified fraction. Next, we have 14 over 6 plus 23 over 12. If we look at the denominators, we can see that 6 and 12 have 12 in common, 36 in common, and 48 in common. The least common denominator would be 12. So, if we multiply 14 over 6 by 2 over 2, we get 28 over 12. And since the other fraction has 12 in the denominator already, we can just bring it down. Now, since the denominators are the same, we can add up the fractions to get 51 over 12. Now, 51 over 12 is not simplified. If we write the numerator and denominator as product of primes, we get 17 times 3 in the numerator and 2 times 2 times 3 in the denominator. We can cross out the 3's to get 17 over 4, which is the simplified fraction. Finally, we have 19 over 6 minus 23 over 12. If we take a look at the denominator, we can see that the LCD is 12. So, if we multiply 19 over 6 by 2 over 2, we get an equivalent fraction 38 over 12. We bring down the other fraction, and at this point we can use our understanding of subtracting fractions to get 15 over 12. 15 over 12, written as a product of prime, is 5 times 3 divided by 2 times 2 times 3. We can cross out the 3's, and we're left with 5 over 4, which is the simplified fraction. And there we have it. We added and subtracted fractions with different denominators.